Hello, my name is Andrey Telegin, and I'm going to present you the work titled as the experimental observation of strain-photon coupling for MAGNETOSTRICTIVE magnetics that has been conducted in the Laboratory of Magnetic Semiconductors of Institute of Metal Physics. At present, a new branch of spintronics called as STRAIN-PHOTON is being intensively developed. It studies the changes in the physical properties of materials due to the deformations emerging under the action of various external fields. On the other hand, it's well known that the optical properties of magnetics are also sensitive to magnetic field and stresses, and there is almost no direct experimental data about possible correlation of absorption of light with deformation in strain-photonics materials. Here we demonstrate the results of study of infrared magneto-optical properties of cobalt magnetostrictive ferromagnetics. Here are the spectra of reflection coefficient, optical conductivity, and light absorption for samples. The optical spectra are formed by the absorption edge below 2 microns, impurity bands in the middle infrared range, and phonon bands. The application of the external magnetic field changes the position of the absorption edge and impurity bands, leading to the pronounced magnetoabsorption effects for unpolarized light with complete spectral behavior. It should be pointed out that the magnetoabsorption depends not only on the magnitude of the magnetic field, but also on its orientation relative to the crystallographic axis of the crystal. It's also important that the estimated possible contribution of the Faraday effect in our case was almost 10 times less than the observed magnetoabsorption. The most distant relationship between magnetostriction and magneto-optical properties of cobalt ferrite is manifested in magnetic field dependencies of magnetostriction, magnetoreflectivity, and magnetotransmission effects. For comparison, one can see also the field dependencies of magnetization and Faraday effect. It's easy to see that the spectral field behavior of magnetotransmission and magnetoreflection is fully consistent with the field dependencies of magnetostriction, and therefore can be explained by the same mechanism. The minima and maxima of the magnetoflexion and magnetotransmission practically coincide with the position of the extrema for magnetostriction for different crystallographic orientations, which points to the strong relationship between magneto-optical effects and magnetostriction in cobalt ferrite. Our experiments also showed a good correlation with theoretical prediction made in the model of mobility of the top of valence band of cobalt ferrite placed at the X point of Brillouin zone. The details can be found here. Here is the conclusion. The strong magnetoabsorption of polarized light and Faraday effect in cobalt ferrite was studied in the infrared spectral range. The strict correlation of the absorption and reflection of light with magnetostriction of ferrite was demonstrated for the first time. And the magnetic field induced the influence on the optical properties of cobalt ferrite while the crystal lattice deformations due to the magnetostriction. And the observed phenomena may be also found in metals and polymers with high magnetostriction. That's all. Thank you all for your attention.